Hello guys, this is the third video for the pH calculation. In the first two we have discussed a pH calculation for the mixture of strong acid, mixture of strong base and mixture of strong acid and strong base. This video we are going to discuss the pH calculation for the mixture of strong acid with the weak base. Most important part of the pH calculation, strong acid and weak base. Here you see strong acid and weak base, obviously they will react with each other, they will form the salt plus water. We know that acid base react gives salt plus water. Here the milli equivalent of the acid and base is very important. Based upon the milli equivalent we will have three different cases. What three different cases? First case, the milli equivalent of the acid and milli equivalent of the base can be same. In that case this belongs to your salt hydrolysis categories. You have idea of the salt hydrolysis? I hope you have little bit. Salt hydrolysis, salt of weak acid or strong base, or salt of weak base and strong acid, or salt of weak acid and weak base can react with water and produce a new molecules. That's we say the salt hydrolysis. But salt of strong acid and strong base cannot react with water and doesn't produce new molecules. Therefore we say the salt of strong acid and strong base doesn't undergo salt hydrolysis. Salt hydrolysis takes place when at least one part is weak, either acid part is weak or base part is weak, or both are weak. If both of them are strong, no salt hydrolysis. For example, your NaCl solution, if you dissolve in water, there is no reaction with the water and the solution is neutral, and that we say there is no salt hydrolysis. Clear? Here what it can happen, the milli equivalent of the acid and base are same, then it will go for the salt hydrolysis. In case of salt hydrolysis, here this is the strong, this is the weak. Therefore I suppose you could understood that as the strong is acid and weak part is base, the resulting solution will be your acidic, because this is the strong, this is the dominating part. In this case the pH is nothing but 7 minus half pKb plus log C. 7 minus half plus pKb plus log C. What is pKb? pKb is nothing but minus log of Kb. This Kb is the dissociation constant for the weak base. And these values will be given, either Kb will be given or pKb will be given. And C is the salt concentration. C is the salt concentration. C is the salt concentration. That C is nothing but milli equivalent either of acid or base. Both of them are same. Milli equivalent of acid or milli equivalent of the base divided by total volume. That is called the C. By using this relation we can calculate the pH. pH is equal to 7 minus half pKb plus log C, because acid part is strong. As acid part is strong, the pH will be less than 7. Or case 2, what it can be? Milli equivalent of acid, strong acid is greater than milli equivalent of the weak base, N2V2. In that case, strong part is higher than the weak part. In that case, obviously resulting solution will be acidic. As a resulting solution will be acidic, there will be H plus concentration. This is as simple as the mixture of strong acid and strong base. This will be your N1 V1 minus N2 V2 by V1 plus V2. Simple as like of a mixture of strong acid and strong base. The case 3, milli equivalent of the strong part is lower than weak part, N2V2. In that case it will form a buffer solution. New terms are coming. Buffer solution. Milli equivalent of the acid is lower than milli equivalent of the base. You will form a buffer solution. In this case the weak part is basic. Therefore this buffer will be your basic buffer. It will be basic buffer solution. For basic buffer solution, calculate the pH. We should first calculate the pOH. pOH is equal to, I suppose that is pKb plus log salt concentration by base concentration. pOH is equal to pKb plus log of salt concentration by the base concentration. Little difficult. What is the salt concentration? What is the base concentration? I will take an example and explain that. This is the relation to calculate the pOH. This equation is called your Henderson equation. I suppose you know that. This is called your Henderson equation. This is for the for basic buffer. Once pOH is calculated, we know pH plus pO is equal to 14. Once pOH is calculated, the pH can be calculated by subtracting from 14. We know pH plus pOH is equal to 14. Therefore, if you calculate the pOH, we can calculate the pH. pH will be your 14 minus pOH. This is how we can calculate the pH for a mixture of strong acid and weak base, provided milli equivalent of the weak base is higher than the milli equivalent of the strong acid. This is the case 3. And when milli equivalent of the strong part is greater than the weak part, is simple, as like as strong acid and strong base, the solution will be acidic. Acid means S plus concentration will be N1 V1 minus N2 V2 by V1 plus V2. If both of them have the same milli equivalent, this is the case of for salt hydrolysis. In this case, the weak part is the base. Weak part is the base. Therefore, the solution will be your acidic, because strong part is the acid. Acid will dominate. The pH will be less than 7. The pH is equal to 7 minus half pKb plus log. So there are so many formulas. You need to understand that. The case to case, the relation changes. If both milli equivalent of acid and base are same, it goes for salt hydrolysis. Salt hydrolysis, cationic hydrolysis, anionic hydrolysis, and cation anion both hydrolysis. We know the case. In this case, what will be there? Anionic hydrolysis. Anionic hydrolysis, for which the pH is 7 minus half pKb plus log C. The value of pKb will be given, either Kb will be given or pKb directly will be given. C is the salt concentration. That salt concentration is nothing but N1 V1 by V1 plus V2. But if milli equivalent of the strong part is greater than milli equivalent of the weak base, it is simple. Resulting solution will be acidic. S plus concentration will be N1 V1 minus N2 V2 by V1 plus V2. Third case, when the milli equivalent of the weak part is higher than the strong part, it forms a buffer solution. What is buffer solution? What is buffer solution? Yes, a solution which resists the change in pH. If we add a small amount of acid or base from the outside, that kind of solution is a buffer solution. The pH remains constant. Like our blood is a buffer solution. We used to take acid. Lemon, mango, they are citric acid. Even sometimes we used to take the base, baking soda, baking powder. pH doesn't get changed. Of course, I am telling we are taking that baking soda in a small amount, or lemon also we are taking small amounts. But if you take large amount of acid and base, not advisable. Direct connections to the heaven, don't do that. A small amount of acid and a small amount of base, like lemon, mango, citric acid or the baking soda, if you take a small amount, the pH of the blood doesn't get changed. We can tolerate that. That kind of solution is called buffer solution. But if we had excess amount, strong excess amount, in that case pH will get changed. In that case there will be so many different cases and there will be casualties. Buffer solution means when a small amount of acid or base is added from outside, pH doesn't get changed significantly. I am not getting it doesn't get changed at all. It may change, but very small amount, insignificant. When weak part is higher, milli equivalent of the weak part is higher than the milli equivalent of the strong part, then it goes for the buffer solution. We know we have three types of buffer: acidic buffer, basic buffer, and salt buffer. In this case, it will be basic buffer. For basic buffer, the Henderson equation is PO is equal to pKb plus log salt by base concentration. What is the salt by base concentration? Let me explain that little bit by taking an example. Very important. Suppose we take hydrochloric acid and ammonium hydroxide, weak base. Therefore, they will react. They will form ammonium chloride plus water. Suppose this is 200 ml. This is 0.1 normality. This is 100 ml. This is 150 ml. 150. Sorry. This will be higher than the other case. This 250 ml. This is 0.1 normality. Therefore, milliequivalent of this will be 20. Milliequivalent of this will be 25. Product of volume and normality. Therefore, they will react with each other. Here, this is 20, this is 25. This is the limiting reagent. This is less in amount. Milliequivalent of this is less. This is limiting and this is excess. Milliequivalent of this is 20. Milliequivalent of this is 25. This is small in amount. This is large in amount. That's why it's called excess reagent. This is called the limiting reagent. Once they will react, what will happen? They will form salt. The milliequivalent of the salt will be same as the milliequivalent of the limiting reagent. Therefore, what we will get? Here we will get 20. And here, how much will left? 25 minus 20, that will be 5. How much here will left? It will become 0. 20 will react with 20. 5 will left behind. And this 20 will completely convert to the product. 20, it left 0. Limiting reagent becomes 0 at the end of the reaction. Excess reagent, why is called excess? Because some amount left behind. Here 5 milliequivalent left behind. Now what we are having? We are having these two. In the mixture. One is weak base, another is salt. Weak base and its salt with strong acid is called your basic buffer. Basic buffer. Weak base and salt of the weak base with strong acid. That mixture is called your basic buffer. In this case, it is forming a basic buffer. Therefore, this is the milliequivalent of the salt. Therefore, C, concentration of the salt. Concentration of the salt will be milliequivalent by total volume. What is the total volume? 200 plus 250, that is 450. That is called your salt concentration. Milliequivalent of the salt by total volume. 200 plus 250, that is 450. And what is the salt concentration? What is the base concentration? Base concentration will be your how much? Milliequivalent. What is the milliequivalent? 5 divided by total volume, that is 450. That means first you need to calculate the milliequivalent of the acid, milliequivalent of the base. You need to identify which one is the limiting reagent, which is the excess reagent. Then they will react with each other. They will form salt plus water. Milliequivalent of the salt is same as that of the milliequivalent of the limiting reagent. After reaction, limiting reagent becomes 0. Therefore, this 20 milliequivalent converted to the 20 milliequivalent of the products. Here, this 20 will react to the 20, 5 milliequivalent left behind. That is the excess. And concentration is nothing but milliequivalent by the total volume. Now, this is known to us. Salt concentration is known to us. Base concentration is known to us. And this value will be given to us. If this is not given directly, Kv value will be given. And we know pKv is nothing but the minus log of Kv. Therefore, we can calculate the pOH. Once pOH is calculated, we know pH plus pOH is equal to 14. Therefore, we can calculate the pH. pH equal to 14 minus pOH. Clear? Here in this case, suppose pKv value we can consider as 4.7. Suppose pKv value is 4.7. Then what will be the pH? First, we need to calculate the pOH by using the Henderson equation. pOH will be your pKb means 4.7 plus log of salt concentration. Salt is what? 20 by 450 divided by base concentration, what? 5 by 450. Therefore, 450 cancel. 20 by 5, that is 4. Therefore, we will be getting 4.7 plus log 4. Log 4 means 2 log 2. 2 log 2. Therefore, 4.7 plus 2 into 0.3010. This will be the pOH. Therefore, pH will be 14 minus 4.7 plus 2 into 0.3010. This is how we can calculate the pH for a basic buffer. Could you follow? This case, let me recap. We can have three situations. When you mix strong acid with weak base, we can have three situations. What are the three situations? Milli equivalent of the strong acid and weak base may be same. In that case, it is a case of salt hydrolysis. As the base is weak, it will go for your anionic hydrolysis. Therefore, as the acidic part is strong part is acid, therefore solution will be acidic. Therefore, pH is equal to 7 minus half pKb plus log C. Log C is the salt concentration. As the milli equivalent of the acid and base, both of them are same. Concentration nothing but milli equivalent of the acid or base divided by the total volume, and pKb values will be given. This is how we can calculate your pH for the salt hydrolysis case, first case. If the milli equivalent of the strong part is higher than the weak part, it is normal case, as like a mixture of strong acid and strong base. As acidic part is strong, the resulting solution will be acidic. H plus concentration is nothing but milli equivalent of the acid minus milli equivalent of the base by total volume. Once H plus is known, we can calculate the pH. The third case is very, very important. When the weak part has higher milli equivalent than the strong part, in that case, it forms a buffered solution. In this case, as the base is the weak, it will form a basic buffer. Acid will react with the base, it will form the salt plus water. This acid is the limiting reagent, base is the excess reagent. After reactions, the limiting reagent becomes 0. Milli equivalent of the limiting reagent will be same as the milli equivalent of the salt, and the excess base, 5 milli equivalent of the base, will remain behind. Therefore, this is a case of basic buffer. In case of basic buffer, the Henderson equation is PO is equal to pKb plus log of salt by base concentration. The salt and base concentration is the concentration after the reaction, not the initial concentration. Please keep in mind that salt by base concentration, that concentration is after the reactions. In this case, the concentration of the salt will be 20 by 450. 450 is nothing but the total volume, 200 plus 250. Similarly, base concentration will be your remaining milli equivalent of the base is 5 by total volume, 450. Therefore, pKb value will be given. We can calculate the pH. By calculating the pH, we can calculate the pH. But since we know pH plus PO is equal to 14, this is how we can calculate the pH of a mixture of strong acid and weak base. Okay, clear? We'll continue in the next video. We'll continue the other two cases. Okay, thank you guys.